Okay, so we were talking about these limits and looking at some graphs and the one-sided and two-sided limits and talking about how things break down. When does a limit not exist? Okay, so we already talked about this in the last video, this notion of a one-sided limit, a right-hand limit. So as we're approaching the number from the right, what are the y values going to, as opposed to a left-hand limit when you're approaching the number from the left. Okay, what are the y values going to? Okay, so we have these, right hand and left hand limits, or one-sided limits. Okay, now here's what's important. Okay, for the limit to exist, the right hand limit and the left hand limit have to be the same. Okay, if the right hand limit and the left hand limit are different, then the limit doesn't exist. Okay. And so this is the important thing here. So notice if the right-hand limit is some number L and the left-hand limit is some number L, and if these L's are exactly the same, then that's the limit, the two-sided limit, okay, of the function. Now, when we talk about just limit, okay, we're referring to a two-sided limit. So if I just say, what's the limit as x approaches c? That means a two-sided limit. So that's usually what we're talking about. Okay, we don't deal with only one-sided limits on a regular basis. Okay, almost across the board, we're always dealing with a two-sided limit. But the only way that that limit will exist is if the right-hand and the left-hand limit are exactly the same. Okay, so we take a look at some things going on with something like this. We'll look at a couple more of these diagrams. Okay, so let's see. Okay, notice that some of these are one-sided limits here and here, and then down the bottom they're two-sided limits. So if we take a look here, the limit as we approach -4 from the left. Okay, so we're approaching -4 from the left. Okay, so here we come coming down the x-axis, and we say, okay, all of our y values are up here as we approach from the left. Okay, and notice that as we approach from the left, we are approaching this point at -4, 3. Okay, so the y values as we approach from the left are all approaching 3. So the left-hand limit would be 3. Okay, now as we approach -4 from the right, okay, coming in from this way, notice your y values are all down here. Okay, and we're down here at what, -4, -2. So as we approach from the right, okay, our y values are all approaching -2. Okay, so if you look here, notice the left-hand limit and the right-hand limit are not the same number. So that means the limit, which we're referring to, this is a two-sided limit, two-sided, okay, that guy doesn't exist. Okay, because the left-hand limit and the right-hand limit are different. Okay, now we look at, okay, approaching -1 from the left, approaching -1 from the right, our two one-sided limits, and then our two-sided limit. So we say, okay, what's going on as we approach -1 from the left? Okay, so here's -1. And we're approaching -1 from the left, so all the y values are going up here to this point, okay, at -1, 4. Okay, so as we approach from the left on the x-axis, all your y values are getting closer and closer to 4. Okay, and then if we approach from the right on the x-axis, notice all your y values are up here. But again, they're approaching 4. Okay. So since the left-hand limit and the right-hand limit are exactly the same, the limit does exist, and it would be 4. Okay? So that's what's going on. Okay? Different one-sided limits means the limit doesn't exist. Same side one-sided limits mean the limit does exist. Okay. Well, let's see what's going on in this guy. All right, now notice these three right here, they are two-sided limits. Okay, they're not one-sided limits. Okay, because notice we don't have any plus or minus that comes after the number down here. Okay, so we're looking what's going on, assuming this is all f, okay, right here. What's going on as we approach -3? Okay, so as we approach from the right, the y values are up here. Okay, as we approach from the left, the y values are down here. So notice the right-hand limit is one thing, the left-hand limit is something entirely different. So since the one-sided limits are different, the limit doesn't exist. So this would be a DNE. Okay? All right, now we approach -2. Okay? So as I approach -2 to the right, okay, here's my y values. Looks like they're approaching 0. Okay? And as I approach -2 from the left, okay, my y values would be coming down here. It looks like they're going to 0 as well. Okay? So if the right-hand limit is 0 and the left-hand limit is 0, then the limit, okay, two-sided limit would be 0 as well. Okay, now we're approaching +2. Okay, and remember that's a two-sided limit. So notice, okay, as I approach from the right, my y values are all up here. Okay, and we're getting closer and closer to this removed point, okay, right here. Okay, but notice that as I approach 2 from the right, the y values are approaching whatever the y value of that point is. And then as I approach 2 from the left, again, those y values are all approaching the y value of whatever that point is. Okay, so the limit from the right and the limit from the left will be exactly the same, so the limit does exist. Okay, and let's see, it looks like it is this point right here, and I know it's removed down here, but this point right here that is removed looks like it's at 2 and -0.5. Okay, so the y values are approaching -0.5 from the right, and the y values are approaching -0.5 from the left. So the two-sided limit would be -0.5. Now this is a really important, okay, situation to take a look at, because notice that f of 2, okay, is down here. Okay, even though the limit exists up here at -0.5, because that's what the y values are approaching, notice that f of 2 is removed. Okay, so just because you remove a point like this doesn't mean that the limit doesn't exist. We're over here, notice we're not removing a point, this guy is jumping up and down. Okay, and so the right-hand limit and the left-hand limit are entirely different, therefore the limit doesn't exist. Okay, all right, so let's see if we can do one more of those guys. All right, if we take a look at these guys, notice they're all two-sided limits. Okay, so let's take a look at the limit as we approach -4. Okay, so I got to go from the right and the left. Okay, so right here, and notice that that point at -4, 2 is removed. Okay, that guy's gone. Okay, but notice that as we approach -4 from the right, okay, like this, your y values are approaching 2. And as we approach -4 from the left, notice that your y values are approaching 2. So even though that point is removed, okay, the y values are still approaching 2 as we get closer and closer to -4 from both the right and the left. So the limit would be 2. Okay. Now here, we're approaching 1 from the right. Okay, notice that the y values here, okay, are approaching -2. And then notice as we approach 1 from the left, the y values up here are approaching 4. So notice that the left-hand limit would be 4, but the right-hand limit is -2, and since they're different, we don't have a limit, okay, at 1. So that would be DNE, okay? All right, now we're approaching 6. Okay, so let's see. We're approaching 6 from the right. Okay, so our y values are up here, and notice that as we get closer and closer to 6 on the x-axis, the y values are approaching 5. And here we approach 6 from the left, okay, on the x-axis. So notice as we get closer, your y values get closer and closer again to 5. Okay, so the right-hand limit at 6 would be 5. The left-hand limit at 6 would be 5. So the limit is 5. And notice that happens even though the point is removed. Okay, just like over here. If you just remove a point, okay? It doesn't affect the limit in most cases. It's when you're jumping up and down, okay? That's what affects the limit. All right.